Okay, good. I'm sharing my screen again. And before we move on to that one, anybody wants to give a try on what is replication factor and search factor, where it belongs to? Is it only for search cluster or indexer cluster or both? Anybody wants to give it a try?
Both belongs to indexer cluster only.
Okay, so
in the replication factor is the number of buckets we maintain in the indexer. Search factor is among those how many are searchable. That is the search factor.
Okay, so they both are only related to indexer cluster. So
Yes.
search cluster does not have any search factor or replication.
In multi-site clustering, the search factor will come into the picture in search cluster.
Okay.
That is only those points.
Yeah, that's fine. I mean, you gave it a try. So replication factor is not related to search cluster?
Yes.
It is even for single site also replication factor is there.
Replication factor is for indexer cluster only.
When search also there.
Search also there. On the indexer cluster, the multiple opinions. Okay. Good, but yeah, it's like there are multiple opinions. Let's see that one. Actually, in short, replication factor. Indexer cluster has its own replication factor. Search cluster has its own replication factor. So only search factor is related to indexer cluster alone. Replication factor for indexer cluster we have a separate replication factor. For search cluster we have a separate replication factor. Sounds confusing, right? I know. So let's discuss that. So what is it exactly? What is it doing? What replication factor is doing on the search cluster, right? So I think Suresh said that one, right? Okay, I marked him. Nice. I'm sharing my screen.
Yeah, Morgan.
No, I said like who said that replication factor belongs to search cluster as well?
Myself.
Yeah, okay. Do you want to give a clarity on like why it belongs to search cluster? Any just
since I have a cluster setup is there in the search also, right? So we wanted to share across the that's the reason we are using that.
Yeah, the answer is correct. Search is also a part of cluster, so it need to replicate. But what does it exactly replicate?
Knowledge objects.
Only knowledge objects?
Knowledge objects. Artifacts. There are many artifacts.
Search artifacts and knowledge objects.
Exactly. Search artifacts and knowledge objects. So these are all the key things. Okay.
Yes.
Okay. So now let's discuss that in a story. Like now this is the answer, but how it happens, what it happens, let's discuss that. Is my screen visible?
Yes, yes.
Okay, good, perfect. Okay, so let's assume now we have a this is search head cluster, search head cluster, and we have an indexer cluster. Of course, like indexer cluster should have a master, cluster manager, and search head cluster should have a deployer. Okay, DP. Right. So this is our environment, right? First of all, why do we need a cluster basically? So cluster is to provide high availability. So in indexer cluster, why do we need in indexer tier, why do we need an indexer cluster? Because we need to provide high availability for data, right? High availability for data. In search cluster, high availability for search artifacts. So what are the search artifacts? Nothing but the search results, whatever information related to the search. So we call them as the search artifacts. Okay. So search cluster is going to provide you high availability for search artifacts. Indexer cluster is going to provide high availability for data. Okay. So this is the two different main reasons why are we using clustering in Splunk, right? Now let's come back. So let me just erase all this thing. Okay, so you implemented a search cluster, indexer cluster. You configured, you selected 3 searches, 3 indexer. Everything is fine. Now you start onboarding the data. Data is coming. The universal forwarder is sending the data to any one of your indexer. Okay, in this case, there is a indexer cluster. Okay, I'm sending universal forwarder sending data to indexer 2. This is indexer 2, right? So now, as soon as the data comes, okay, as soon as the data comes to the indexer, the first it gets compressed and stored as a raw data journal, raw data journals. It just get compressed. So it get compressed up to 15%. Okay, let's say you are indexing 100 MB of data. This forwarder is sending 100 MB of data. That gets compressed up to 15%, which means only 15 MB of data will be stored. Raw data will be stored. This is what happens first. As soon as the raw data gets stored, indexer cluster will check what replication factor you configured. Okay, let's say you have selected replication factor 3, search factor 2. Don't worry, why did you select? Somebody told you, you selected. Okay, don't worry how to decide. Now somebody told you to keep replication factor 3, search factor 2. Okay, now as you configure this one, this indexer will check what is the replication factor. Now you set replication factor 3, which means you are asking the indexer cluster to store 3 different copies of this raw data. So this is first copy and 2 more copies will be stored. So this data gets replicated. This raw data gets replicated across 2 different places. So in indexer 1, indexer 2, indexer 3, so 3 places the raw data gets replicated. This is what happens first as soon as the data comes into your indexer, right? Now replication factor 3, which means 3 raw data copies should be maintained. Condition is satisfied, right? Now once the replication factor is satisfied, then the second one indexer checks is search factor. Search factor 2, you gave search factor 2. Now what it does is it creates a TSIDX file. In any of this copies, it will create a TSIDX file. So it will create additional TSIDX file here, and any one of the place there will be a TSIDX file. So search factor 2 means how many raw copies will have a TSIDX file. Hang on. I know I can understand what is the raw data. What data is something, whatever I'm sending, I'm just storing it. Clear. And what is this TSIDX file? That is something Splunk is creating on its own. No, it's not like that. Splunk is actually extracting the unique keywords from the raw data and creating it as a TSIDX file. So this is something called time series index files. Okay, if you want to understand what is time series, in our textbooks we have a index, right? In the back, the book back, we'll have an index, right? Let me show you how it will look like. I mean, many people might have seen it, but we might have not noticed it. My internet connection is very slow. Okay. Yeah. So this is actually the index. So in your textbooks, you might have seen this kind of things. So what is this used for in our textbook? So let's say you want to find a particular keyword, right, in your book. You don't want to go through thousands pages every time, right? So you simply turn your book and you go to the index page and you check for this particular keyword, and this index will tell you in which page number this keyword is present, right? You are directly going to open that particular page and you will find it. So this is how we are using it in our real life, right? The index we are using. So the same principle is being used in the time series index. So raw data, 100 MB of raw data will be huge, right? There will be too many events, right? If you're just looking for one keyword, how do Splunk know in which event that particular keyword present? So first, Splunk, what it will do is it will take your, it will take your search. Whenever you're searching, whenever you're triggering any search, it will first go to the TSIDX file, and then it checks, like how I did it in the book page, right? It will read the unique keywords and it gets the page number. Then it will go to the raw data. Your search will never go to the raw data directly whenever you're executing any search, right? So this is the process. It always checks for the TSIDX file. Only when there is a TSIDX file, then search it is considered as a searchable copy. Okay. So whenever you trigger a search, your search will go to TSIDX file. It checks the page number and it takes the page number. It will go to the raw data. So we call this as a raw data journal. Okay, in Splunk index, in Splunk documents, you might have seen it, they call it as a raw data journal. Why are they calling it as a journal? Journal means multiple pages. That's it, right? So in our real time, you have newspaper journal, multiple pages. That's why you're calling it as a journal. Here also they are calling it as a raw data journal. This similar. It has a journal has an index. So you are just going to the index, you are checking the particular term, and then you're going to the right page number. If you want to understand whatever I said in a visual format, there is a free video available in Splunk website itself. The name called Search Under the Hood, e-learning. If you open that, whatever I said, it's clearly animated over there. Maybe Ramani can share that link in the chat. You can watch that when you are free time. See, this is really important concept, because tomorrow when you're facing performance issue, when you want to scale anything, without understanding what is replication factor, search factor, you cannot fix your performance issue, because this is what the root of all the issues. Okay. And if you want to store disk storage, or if you want to improve scalability, many things, right? Everything starts from replication factor and search factor. Okay, coming back to this one. So TSIDX file is needed in order to make the data searchable. So now this file, this copy is searchable, this copy is searchable. Here I have a third copy, right? In this third copy, I have only raw data. Here I don't have a TSIDX file. Then this data becomes non-searchable copy. So replication factor, search factor decides how many copies you have. In that, how many searchable copies, non-searchable copies we are going to have. So that is what decided by replication factor and search factor. Is it clear, or you want me to repeat in a different way? Are any doubts in this?
The search factor means the number of TSIDX file per indexer.
Not number of TSIDX file, number of copies that is going to have a TSIDX file. So replication factor will tell you how many bucket copies. Search factor will tell you how many of those bucket copies are searchable.
Okay. Thank you.
Yeah. Okay.
More than.
Yes.
So
Okay.
if we two indexes got down, which having TSIDX files.
Yeah.
Like performance will be slow, or like how, what
Yeah,
exactly?
that is the last part of this session. We'll discuss it actually. But before moving on to that one, are you clear what is replication factor and search factor?
Yeah.
Yeah. Okay.
One, I'm not sure whether I can answer the question now. So you said, right, 15% of data will be compressed.
Yes.
From the 100 MB, like say for example, 15 MB will be compressed. What about the rest of things?
No, it will be compressed. The 100 MB will be compressed and the size becomes 15 MB.
15 MB, okay.
Yes. Every data, all data will be there. It's like how you are creating a zip file in your laptop, right? You just compress it. The same way it happens here.
Okay. Yeah, thanks. And the next question, not sure, like if I can ask, like the number of copies, like how are we deciding?
That is actually a different question. That's not for today's session. That is architect decision. Yeah.
No, my query is like, see, now we have 3 indexers clusters.
Yes.
So even replication factor also we consider as 3. So like, is it like the same?
Yeah, no. Actually, minimum you can keep the replication factor 3. That is minimum suggested one, because you don't want to lose the thing. In order to have a high availability, minimum 2 also you can keep replication factor 2, because in order to have high availability, you should have a copy. If one goes down, another thing should have. So minimum replication factor should be 2. Search factor should be equal or less than the replication factor.
Okay, so now if I have 4 clusters, 4 or 5 clusters, indexer clusters, so like at the time also I can have like only 3 replication factor.
Yes. If it is a multi-site cluster, you can have it. So there, like 3 means, are you keeping 3 copies in across the cluster, or in each cluster you are going to have a 3 copies? That is something multi-site cluster concept. You can decide.
In single site.
Single site?
Say for example, I have 5 indexer clusters. I have 5 clusters. So if I say RF3, so how it will store it? Whether it
No,
will store in
you
all
see,
5 indexes.
when you say 5 cluster, right? 5 different clusters or
Means
5
indexer
indexer with one cluster.
Now we, for example, now we have three indexer cluster, right?
No, we have 3 indexer. It's not cluster. We have one
Yes,
cluster
correct.
with the
Yes,
3 index.
indexer,
Ah,
three
that's,
indexes. So
yeah,
now
yeah.
I have 5 indexers.
Okay. Now I understand your question. So
Yeah.
if I have an additional 2 indexer, so where this copies will be stored, it's completely random. You're not going to decide. So it's like as soon as the data comes, the primary copy, first copy will be stored the moment in the same server where the data is received. The second and third copy gets stored randomly. It may go here, or it may go here, or it may go here. It's completely random. Cluster manager decides that.
Okay, so it is not like always 100 all 5 indexers that data will store.
It's not always like that. It is completely random. That's what making it available. So it's not going, you're not going to fix it. Like if you are keeping replication factor 5, yes, in all indexers your data will be there.
Okay.
Yeah, but if you keep replication factor 3 with 5 indexers, you cannot say all indexers are having the all data. No, you cannot say. Yeah.
Thank you.
So Murugan, here, if the replication factor will be 4, the search factor will be 3, or it can be 2.
No, search factor can be less than replication factor. You can keep 3, 4, 2, anything you can keep. So it should be less than replication factor. That's it.
Okay, I thought it should be n-1, something like that.
Yeah, n-1. You can keep n also. You can directly keep replication factor equal to search factor. You can keep both, but there will be a risk whenever something goes down. And see, when you say replication factor 3, search factor 3, right? You are having multiple copies of searchable copy. It's going to take your storage. It's like architecture side concern. So best practice is to keep n-1. That's of course, but technically it is possible to keep replication factor and search factor same.
Okay.
Yeah. Okay. I think yeah. Thank you. And I'll come to here. So this is how in indexer cluster we have a replication factor. Replication factor means how many raw copies. Search factor means out of those 3 copies, how many raw copies are going to have a TSIDX file. So this is what replication factor. Okay. Now in the searched cluster, what is going to get replicated? Because in the indexer the data is getting stored, as people said in the beginning. So in the searched cluster, we need to store the search artifacts. Search artifacts. What are those? What does it mean by search artifacts? Anybody want to give it a try? Search.
Yeah, reports, alerts, fields, all those queues. If you in settings, if you see open, there is a knowledge of all those comes from the search.
Those configurations you are saying, or the results you are saying?
Results also. Results of job search result. That will also an artifact.
Exactly, because a search artifact, for example, today you are running. Okay, do we have any questions in the Q&A section?
The question what we are addressing, Murugan.
Okay, fine. So now in the search head, right? Let's say your user is searching, triggering one search. The search head will go to the indexer cluster, and the indexer cluster will execute the search, and it will send the result back. The search head is receiving the results, right? If you see, by default, your search results will be stored, I think, for 10 minutes, I believe. Yeah, it will be available for 10 minutes, right? So till that 10 minutes, where are those results get stored? They get stored on your search head disk. So if any chance, like if this one of the search head goes down, you are expecting the results, whatever you got, just within 10 minutes, you want that results in any of the 2 search head. So making sure your search results are available at any point of time, that is being done by the search artifact replication. So search heads are replicating the search artifacts, of course, the knowledge bundle, all those things, but search artifact replication is controlled by the replication factor on the search head. So many people confuse search factor is related to search head cluster, replication factor is only related to index. No, replication factor is related to both, but both are different things. In a search head cluster, it is controlling the search artifact replication. In indexer cluster, it is controlling data replication. Okay. Okay, so this is the difference between replication factor and search factor, and this is the difference between replication factor on the search head, replication factor on the indexer, right? So now, so let's understand the scenario. What I think Naga asked, I believe. So at the if we have multiple indexers, let me see. So this is indexer 1, IDX 1, and this is indexer 2 and indexer 3, let's say indexer 4, right? So now I gave replication factor 3, search factor 2, right? Now I am the data is coming here. So as we discussed earlier, so replication factor makes raw data stored in 3 different places. Let's say I'm storing it here because it completes random. So I have 3 different raw datas, and now search factor means TSIDX file. This is TSIDX file. And here, let's say, okay, here also I should have, because the main place will have TSIDX file. So replication factor 3 raw data copies, search factor 2, which means 2 TSIDX file got created, right? Now, before we move on to that question, right? Now I have one question for you all. Right? Now, every time we are saying there are 2 copies, right? 2 copies, 2 different searchable copies. So these both are same. Now when my search head querying, will it get duplicate data because I have 2 different copies? Will it get duplicate data, or it will get only unique data?
Unique data only. It will get.
Unique data only.
How does it classify? This is I need only unique data. I have 2 different copies.
The time frame you choose, right? Based on the time frame the set.
It's the same data. Same data. We have it in 2 different indexes. That is what cluster, right? Same data. It's in 2 different places.
Yes.
Then I cannot differentiate with time. My search head is asking, hey, give me data. Now 2 different indexes are standing with the 2 different data. How is it making sure it is getting only unique data? Okay, so this is where there is a primary. It's okay. First of all, this is a searchable copy. These 2 are searchable copy. Okay, searchable copies. This is searchable copies, and this one is non-searchable copy. Okay, this is clear. So even though you have 3 copies, 2 of them are searchable copy. Another one is non-searchable copy. In both of those searchable copies, there is a classification. Primary searchable copy, non-primary searchable copy. So this marking happens on the go, on live. Whenever the data is received, right? Whenever the data is received here, it marks this as this is a primary copy, and what remaining things non-primary copy. So when searched is querying the data, it knows which one is the primary copy, and it takes only the primary copy back, and non-primary copies will not be searched. This is how, even though there is a multiple copies, searched is looking for only primary copy, and it is getting only unique information. Is this clear?
Yes. Yeah, that's correct.
Okay.
The first index where it goes, that will be the primary
Sorry,
copy, right?
please.
Oh, sorry. I mean, the first index which receives the data from the remote machines, that is called as a primary search.
Primary copy. Yeah, primary copy.
Got it. Thanks.
Yeah. Anybody else? I mean, now we'll discuss what happens if this goes down.
Okay, so in that case, now since we have SF2, where one will be the primary and the second will be the non-primary. If the SF is 3,
3 will be
again
then
will be like
another non-primary copy.
Okay.
Multiple non-primary copy. Only one primary, multiple non-primary will be there.
Okay.
Okay, let's say now let's come to the real case scenario. Let's say this primary copy is down. Okay, suddenly something collapsed. Okay, this server is down. This indexer is down. What will happen?
It will search from non-primary.
No. First, what it will do is cluster master will identify, okay, primary copy is down. Cluster master will initiate bucket fixing activity. Okay, bucket fixing activity. What the aim of this bucket fixing activity is, first thing, it will make non-primary to primary. Sudden switch, just a flag. It will make the non-primary to primary. First action. Okay, so that searched will not have an interruption. Quickly, searched can switch to this one and it can get the data, because this is already a searchable copy. I'm just making the non-primary to primary. First action is done. Now, then once the primary copy is being marked, second one, cluster manager will check, okay, what is the search factor? So search factor says 2 searchable copies. Okay, then it will check, okay, in my cluster, do I have any other non-primary copy? Here we don't have a non-primary copy. So based on our condition, our cluster should have 2 searchable copies. Okay, now I already have 1. Okay, in this scenario, 1 searchable copy is there. Now it will look for any other copies. If it didn't find any searchable copy, then remaining non-searchable copy, right? Here it will build the TSIDX file. Cluster manager will instruct this indexer 4 to create the TSIDX file. Now the non-searchable copy becomes searchable copy. Then cluster manager marks it as a non-searchable primary copy. I know it's a tongue twisting multiple things, but yeah, this is what happens. Cluster manager first make sure the primary copy is there, and second, what it will do, it will make sure enough searchable copies. Okay, now this is clear. So this is where cluster becomes valid state. Okay, this is where my indexer cluster becomes a valid indexer cluster, which means search factor is met. Now, the next one is replication factor need to be met. So in order to meet the replication factor, I should have 3 raw data copies. But here I don't have 3 copies. I have only 2 raw data copies. So then what it will do is, it will instruct indexer 3 to get raw data copy from any one of this place. So now this indexer 3 will copy the raw data alone to this indexer. Only raw data gets replicated. Keep in mind that TSIDX file will never get replicated in indexer cluster. Only raw data gets replicated. TSIDX file will be built. It will be built. Okay, it will be built from the raw data. TSIDX here, here it won't be built. Okay, as soon as the raw data gets copied, as soon as the cluster master makes sure the replication factor is satisfied, then the cluster becomes complete. There are 2 stages in indexer cluster when the bucket fixing happens. Okay, so bucket fixing will get triggered when any one of the indexer goes down. The aim of bucket fixing activity is to make primary copy, at least 1 primary copy, and then it will satisfy replication search factor, and then it satisfies replication factor. Okay, so this is what happens if any one of the things goes down. Now we are going to see this in live. Before we move on to live, like anybody have any question? Oh, we are past time. Okay,
excuse me, if the down indexer became up, what happened for the bucket?
That's a very good question. Now, as soon as then this becomes up, right? Now it will have its own TSIDX file and raw data copy, right? So now we have more copies, right? Once this becomes up, cluster master will say, hey, okay, replication factor only 3. I need only 3 copies, but I have 4 copies. And since search factor, I need only 2 searchable copy. I have 3. This is where the concept of excess bucket comes into picture. In your indexer cluster dashboard, if you go to excess bucket status and see excess bucket, you will see like, why is there an excess bucket? I'm giving only 3 options. This is what happens. Sometimes there will be a disconnect, an internet connection. Indexers, it not necessarily like your indexer need to go down. There might be network interruption, service replication issues. So if the downed indexer comes up, it gives an excessive copy. So which is being fixed by cluster manager itself. It will remove the excess copies automatically. Sometimes you need to remove it manually. That's it. But this process happens. Whatever I explained, this happens automatically within the cluster.
Okay, thank you.
No problem. Welcome. Okay. And if no further question, I'll open just the screen and I'll just trigger that bucket.
One question.
Yes.
Number of buckets won't be same in all the indexes if you go to the bucket status one. Any reason is that?
This is the reason. You see now whatever we see, right? See here earlier in this indexer, right? See in the indexer 3, we did not have this bucket. All the other indexer had one bucket. So now this indexer is not having any bucket. Here the bucket count is 0. So here bucket count is 1, 1, 1. You're getting my point?
Yes.
Yeah. I mean, this is controlled by replication factor, search factor. All of your indexers will never have a same amount of buckets unless you have replication factor, search factor equal to the number of indexers. But still, there will be data incoming, right? See now, as soon as the data incoming here, I'll have 2 more bucket copies, which are being created right now. So there will be slight, because the data is coming and going, getting balanced, right? So it will be dynamic. So it will never be same until unless you stop all the live data. There will not be same bucket copies. Even the internal data coming in, right? So that will trigger few buckets going here and there. So that is expected behavior.
Thanks, Murugan. Thank you. It helps me.
Okay, thanks. Yeah. Any further question?
One question. From which indexer the master will remove the excess bucket?
The one which joined last. Because now, you see, now it's a primary bucket here, non-primary here, and here. So this is the one with excess bucket. It joins here. Okay, and this is what being removed. Okay, it will mark it's the excess bucket. And it completely decides random. So there is no proper way. Okay, this is the one, that is the one. But mostly the last one with the primary bucket, it gets removed. Right?
Yeah. Okay. Great. Thanks for that.
Okay. Good. Okay. In the interest of time, I'm just switching to the demo. And if you have any further questions, you can just drop us on the WhatsApp, so we can just explain. Okay. Yeah, here you see now luckily like we have in a lab environment where all the bucket counts are same. But trust me, we are not ingesting any data, so that's why. Okay, so in our AWS, so yeah, I just turned on only indexer cluster. So I have one index cluster manager, indexer 1, 2, 3. So I opened it, you can see everything is green, happy, all data is searchable, search factor met, and replication factor met. So if I go to the indexer cluster, indexes tab, you see this is where it says, see replication, 2 replicated copies, 3 replicated copies, 2 searchable copies. Did anyone say anything?
Yes. Are you sharing screen? Unable to see.
Yes, I'm sharing this.
We can able to see.
We can able to see your screen.
Okay, thanks. Maybe can you rejoin, or can you check your internet connection, please? Okay, good. So now everything is happy. So now I gave replication factor 2, search factor 2, right? So let's say if you see, I have replication factor 3, search factor 2. Clean, everything is clean. Now, whatever I show you, right? Let me do that. So now I'm purposefully going to bring indexer 3. Okay, we will see the bucket fixing activity happening here. It will be quick, guys. So keep an eye. Okay, it will be real quick. So that please make sure you are watching this one. So I'm just stopping the instance. So indexer 3 is going to stop. So quickly I'll go. Okay, let it stop. So indexer 3, man. Okay, you see indexer 3 is getting stopped. You see there is some gray color. You see the third copy is down. Now you see what is happening. It is actually the gray color. It is creating actually. It is creating the TSIDX file. Now the primary copy or one of the searchable copy was down. So now the index, the cluster manager requested the remaining indexer to create the TSIDX file. This is what a bucket fixing activity is. So it's actually doing. You see, it's doing. So you see search factor not met and replication factor not met. So now the cluster is becoming a valid state. Okay. Once the cluster becomes valid state, the search factor will be met. So it is building. Bucket fixing activity is still on. Once this reached, it will become valid. Okay, it's the internal index expected. You see, now this is going down. All our internal indexes do generate data continuously. You see, now search factor met. So now your cluster is valid because it satisfied search factor. Now your users are safe. Your end users are safe because they will get the data continuously. But as an admin, now you are in a limelight. So because you need to have a replication factor met, right? So what is the reason? Replication factor we give 3, but we have only 2 indexers up, right? So replication factor cannot be met. So we are left like this. You see, it's the third bar, it is 0. So this is how the bucket replication, bucket fixing activity happens. Now, what if I bring this indexer back, right? So will it do any fixing here?
Data rebalancing here.
Yeah. See, already there are 2 different searchable copies. Now it just makes sure that replication factor is met. Already search factor is met. Now it will try to match the replication factor. So now let's refresh. It takes time because it need to start and then it need to start Splunk and then it will contact. It's a very thing. But yeah, don't try this in your production environment, please. But if you are the admin, don't worry. Just close your eyes and try. It will work.
So Murugan, how much time we can wait? So assume that initiating the server, which is not in our hands, there was issue with that server. So how much time we can wait?
To make the server up or to complete the bucket fixing activity?
To see, assume that the servers there is a issue with the server. So it will take up to 6 to 7 hours. So what will be the situation in that point of view? How the admin have to react and what has to do?
Wait, let me try to understand the question. The server is down. There is an issue
Correct.
with the server. And
Yes.
you are saying it will take 6 or 7 hours to fix it?
Correct.
Okay. Will there be any issue on this from the business side?
Yes.
Okay. So, I mean, what you need to react means you need to fix it, or I didn't get the question completely. Sorry.
Yeah. So because is there any business loss, something like that?
Yeah, exactly. If the search factor is not met, there will be business loss because if users might not get the enough data. Okay, they might not get the complete data if your search factor is not met. Okay, so make sure your search factor is met. As long as the search factor is met, you are in a safe zone. Okay, replication factor. Yeah, see, replication factor, meeting the replication factor is admin's need. Meeting the search factor is a business need. Okay, so if the search factor is not met, then please drop an email and inform all your user, inform your management. I know it's escalation, but still inform them and try to work on it. But if your search factor is met, you just inform your internal people that you're working on the replication factor. That is enough.
Okay. So until unless the server comes up, the replication factor will not get met, right?
Will not get met, right? Yeah. And if you are continuously, like if it is taking, like as you said, 7 hours or 2 days, right? It is good to introduce a new indexer so that new indexer can get the data quickly and make it available. If it is only 2 or 3 hours, that is fine. But if it is crossing like 6 or 7 hours, introduce a fresh indexer. I know it is costly, but if the business continuity comes priority, then you need to add a new server. Then you work on the old server which was down. So this is how the bucket fixing activity, you see, it did everything. And if you go to the bucket status, right, now you can see indexes with the excess bucket. What is the excess bucket? Because the indexer went down, it was having a searchable copy. Now it again joined. So now the cluster manager is complaining, hey, we have excess bucket. This will get removed eventually. Okay. or you can just click on this remove all access bucket and you can click on confirm. But in your production, when you're clicking this button, be cautious because it will trigger a lot of actions. Your indexer cluster will be busy. So trigger it only when people are not using it. Or
So
you can,
when this will be removed automatically?
yeah, it will be removed. Like when the cluster is like a cluster master talking to the multiple indexers, it gets removed. There is no fixed time frame.
Okay.
Yeah, so I just initiated this one. It gets removed slowly whenever there is action happens. And that too, when you're having terabits, petabits of data, right? It might take days to fix it. And servers will go down. So this will happen, simultaneously, constantly. So you don't need to worry about it. But make sure you're not having lakhs and lakhs of excess buckets. No, in that case, you fix it. If it is only 100 or 200, that is something expected. You see 100, 137, this is something expected. Excess buckets is fine. It's not a problem. Only thing is it will consume the disk space. That's it. Okay. Any further questions regarding this?
So is there a particular time range that the data will get, the access buckets will get automatically get removed? Okay.
Maybe. I don't know. I mean, I never read it anywhere. There may be, but based on my understanding, my experience, no. It just gets automatically removed. Maybe I'll read it and I'll check it out. Good point. Let me not wrong.
And
Okay.
there was one other question, Murugan. So
Uh-huh.
it was regarding whether the user will be aware of anything that is happening in the indexer. So that was
No.
the question.
User
If
will be complete.
indexer goes.
Yeah, user will be completely on the search head. And if the search factor is not met, or if there is no searchable copy, then user might get a warning alert saying like blah, 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 something. I mean, which user never understands. Even as admin, you won't understand what is the error message. So user will get the error message. Yeah, but if the search factor is not met, they will see a problem in like running the search. It will say throw warning like the data is not complete, blah, 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 indexer is not up, blah, something like that. But yeah, user will not be impacted until unless the search factor is not met. Okay, I think we have passed time, so we're almost 1 hour. So any other questions or any feedback or any suggestions or improvement points or any other new topics you want to discuss in the future thing, you can tell me now. Was it okay, or was it too confusing, too much theoretical, or too much tongue twisting?
No. If you have some admin knowledge, right, this would be a great session to understand the things.
All right. Understood.
It's really good, Muruganathan. I have a confusion that search factor, so replication factor in saturated cluster.
Okay.
I mean,
Okay, now you are having a confusion after the session.
no, not now. Before that,
Okay. You have okay.
I knew that, but I didn't
Okay.
concentrate much on that area. But it got clear. And the TX, when the TSIDX will be created, and journal, the wordings no, but in-depth clarity I didn't know, because
Okay.
even though I work in admin, it never got a chance to go such a deep level and say just restart or bucket status. Whatever you did, that's what generally in production we'll do. But this much time won't be have to do deep dive and understand the concept.
Yeah, understood.
Thank you so much. I mean, it will be very useful.
Yeah, thanks a lot.
Yes, Murugan, I had many doubts on these factors. Now I got cleared. Thank you.
Okay, nice. Thanks for this. I need coffee for that. Okay, so when we are meeting, nice. But yeah, thanks for that. Yeah.
Okay, yeah. So will be there any session for that multi-site things or multi-site cluster?
Actually, the infra is the problem. Like running those many servers and showing, right? So for a free webinar, we are trying our best to get the infra. So once we get the infra, it is fine. Or if anybody has any infra like setup, then if you want to collaborate with us to show and explain, we are ready.
Okay.
Yeah, so we'll see. Like we'll find out time. Many people asked a multi-site cluster. Are you asking how to configure or how to work? Like what exactly you are asking in multi-site cluster?
Like the configuration, like how the flow architecture works.
Okay.
I mean, both actually. In many projects, we don't have multi-site. Very huge projects we'll have. So in interviews, when we go, people if they ask on multi-site, it will go. I mean, I
Basic
don't expect
understanding
that
of
free of
the
cost. It is very expensive. I understand. I do not expect people to give it free of cost. It's totally expensive. I understand, and it is also T3, T2 kind of things you have to take. Maybe you can put it for some price in case of multi-site.
But if that is people are expecting, please do reach out to us. Then only we will understand. And if we have good amount of people, then we can do it. So we're ready to do it. But only thing is the server constraint. So if people are ready, multiple people are reaching out, we'll definitely launch.
Yeah. Configuration of multi-site and a couple of examples. How do we integrate and all.
Right. And
I'm okay for that. If I'm one of the person who is looking for that. Maybe sorry I couldn't ping you. I was completely ill many days.
I'm able to understand you. I mean, you guys are Splunk admins. You guys, I know how difficult tasks you guys get. I understand. No worries. See, only thing is like I'll send you the link, the form where you can fill in the topics whatever you want. So that, I mean, of course, every time you can't just reach out to us and talk to us for an hour or something, but please fill out those forms so that we can follow up with you. So
definitely, you can share. We will definitely. I'll do that.
Yeah. Let me put that form here. And this form asks your contact details because we want to know who is requesting the topic and we want to understand what topic really you guys are asking. So please feel free to add your contact number. Then this will be confidential. We won't reveal it outside because this is to make sure that you are requesting and we are receiving the right topic and with the right manner. Okay.
Yes, definitely.
Okay. What about others? Yes, Adisha.
Thank you both. Thank you, Ramani. Thank you, and your team.
Thank you.
Thanks, everyone, and let us know what are the future topics you want. We'll have a discussion in the future.
Thank you. Bye bye.
Thank you, everyone. Have a great day. Bye.
You too. Bye bye.